Hi there and welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're talking about rationalising surds, our first video on this. Now before we get going, let's link to something we've previously done on Hegarty Maths, in particular on the video on multiplying with surds and brackets. What surd could I multiply the following by to get a whole number? Pause the video and check you know. Well, the easiest thing to multiply by here would be root 3, in which case I would get 3. The easiest thing here would be not 2 root 3, but simply root 2, because I know the root 2's multiplied together to give me 2, and I've still got times 2, so it would be 2 times 2, which is 4. And the same thing here, I can just multiply by root 7. No need to have 5 root 7. Root 7 will do the trick for me, because root 7 times root 7 is 7. I've still got a 5 in front, which is multiplying, so that's 5 times 7, which is 35. So we're going to need that skill a lot in this video. Now, linking to one other idea we've talked about previously on the dividing by decimals. Previously on Hegarty Maths, if I asked you to work out or evaluate 5 divided by 0.2, you would have said to yourself, right, I don't like 0.2 on the denominator, so let me multiply the top and bottom by 10. And therefore, what would I get on the top? Well, 5 times 10 is 50. 0.2 times 10 is 2. And it's much easier to work out 50 divided by 2. 50 divided by 2 is 25. So that technique was doing something or multiplying the denominator of a fraction by something to make the calculation easier for us. And a very similar idea is happening in rationalising surds. Let me show you. Here's the typical question. Rationalise 5 divided by root 2. Now mathematicians do not like surds on the denominator of fractions. They do not like. Okay? And to rationalise a surd means to remove a surd from the bottom of a fraction. To do something to the fraction to get rid of that surd. That surd is an irrational number. If you remember, surds are irrational numbers. The aim of rationalising is to make the bottom number a rational number, or a whole number, let's say. So, what could you multiply the top and bottom of this fraction to generate an equivalent fraction by to get rid of a square root or a surd on the bottom? Well, based on what we previously talked about, if you were to multiply the denominator by root 2 and the numerator by root 2, that would certainly get rid of the surd on the denominator, because root 2 times root 2 is 2. And 5 times root 2, a mathematician writes as 5 lots of root 2, 5 root 2. Now, for whatever reason, mathematicians do not mind the surd being on the numerator of a fraction. They're more than happy with having the surd there. Happy days for a mathematician. What they are not happy with is having the surd on the denominator, and they will do a technique called rationalising, multiplying the top and bottom by whatever it takes to get rid of that surd on the denominator. And that's what we're going to do in this video, rationalise various fractions where there's a surd on the denominator. So let's start. Rationalise the following. What do you need to multiply top and bottom by? Root 2 again, isn't it? So multiplying the top and bottom by root 2, I would get root 2 over root 2 times root 2 is 2. The surd is now on the numerator. Mathematicians are happy with that. What about this? Well, I would multiply the top and bottom by root 5. The top would therefore be root 5, 1 root 5. The bottom, root 5 multiplied by root 5 is 5. And again, mathematicians absolutely happy with that. What about here? Well, they would choose root 2, so multiply the top and bottom by root 2. 3 times root 2, a mathematician writes as 3 root 2. Root 2 times root 2 is 2. And the last one, what would they choose? They would choose root 7 and root 7. Okay, 2 times root 7 they write as 2 root 7. Root 7 times root 7 is 7. And there you go, our first introduction to rationalising the denominator of surds. Do you want to pause the video and try the following yourself? What would I do here? Well, again, I would multiply top and bottom by root 2. Okay? Now, on the top, 2 root 2, I'd get there, and on the bottom, root 2 times root 2 is 2. Now in these set of questions we're not quite finished, are we? Because we can simplify that fraction. There's a factor of 2 on the numerator and on the denominator. We can think of it as dividing the top and bottom by 2 or cancelling that factor of 2. And actually that just leaves us with the answer, just root 2, like that. So be careful when you rationalize a surd, the first step. Can you then subsequently actually simplify the resulting fraction? And if you can, make sure you do. What would I do with here? Well, I'd multiply by root 5 and root 5. On the top, I'd get 10 root 5. On the bottom, I'd get 5. 10 over 5, this here, can I simplify 10 divided by 5? Yes, I can. It's the whole number 2. So I'm just going to write this as 2 root 5, and we're done. Next one, I'm going to multiply the top and bottom by root 10. On the top, I'm going to get 5 root 10. On the bottom, I'm going to get myself root 10 times root 10 is 10. Now, can I simplify the fraction 5 over 10? Well, I can. I can divide the top and bottom by 5, and it will be a half, won't it? So I could write that as 1 root 10 over 2. But mathematicians never bother writing the 1 in front of the square root. They just leave that as the following, root 10 over 2. And the last one, multiply top and bottom by root 12. So multiply by root 12, multiply by root 12. What would I get? 3 root 12 over 12. Now, can I simplify 3 divided by 12? Yes, there's a factor of 3 in 3 and 3 in 12. So I can divide top and bottom by 3. And as I said before, I get 1 root 12 over 4. But I don't write the 1, okay? So instead of writing the 1, I'm just going to write root 12 over 4. Now pause for a second here and think to yourself, am I finished? Unfortunately, I'm not finished. Root 12 is a surd that can be simplified. Do you remember in the simplifying surds video? I can write root 12 as root 4 times 3, which is root 4 times root 3, which is 2 root 3. And where possible, you must simplify your surds. So I'm going to replace root 12 with 2 root 3 over 4. And can you see here, there's another fraction, this 2 over 4, I've got to simplify further. And 2 over 4 is just a half. So my final answer to this is going to be root 3 over 2. Now I didn't have to worry about it here. Root 2 can't be simplified, root 5 can't be simplified, root 10 can't be simplified, but unfortunately root 12 can, and you've got to keep your eyes open for those ones. Let's try some more. What should I multiply top and bottom here by? 3 root 7? Not necessary, just root 7. Okay, that will get rid of the surd, that will rationalize the denominator. On top, I'm going to get myself root 7. On the bottom, root 7 times root 7 is 7, and you've still got a 3 multiplying, so 3 times 7, 21. Done. This one here, shall I multiply the denominator by 4 root 12? No need, just by root 12. So I'm going to multiply by root 12 here and root 12 here. On the top, I'm going to get 3 root 12 over root 12 times root 12 is 12, 4 times 12 is 48. Now, this fraction here, can this be simplified? 3 divided by 48? Yes, top and bottom can be divided by 3, and I would get myself the following, root 12 divided by 16. Now, am I finished? No, not quite, because root 12, remember, is root 4 root 3, which is 2 root 3. Root 12 can be simplified, so I need to go back up here and write root 12 as 2 root 3 over 16. Can I simplify 2 over 16? Yes, I can divide top and bottom by 2, and I would get myself root 3 over 8, and I'm done. Next question, we're asked to rationalize the following. So I'm going to multiply the denominator by root 2 and the numerator by root 2. On the denominator, I'm going to get 2. I'm going to put a brackets here just to remind me to multiply everything by the root 2. And because multiplication is commutative, I'm just going to write that first before the bracket because I find it easier to multiply out. So root 2 times 2 we write as 2 root 2. Root 2 multiplied by root 2 is just 2, all of that over 2. And I can divide the top and bottom by 2. There's a factor of 2 here and 2 here and 2 in here. So dividing everything by 2, I just get 1 root 2 there, plus 1 all over 1, and this I can just write as root 2 add 1. Now they wanted it in that form, so I can therefore say 1 plus root 2, where clearly my A is 1, my B is a hidden 1, and my C is 2. And that's it for this video. Thanks for watching.